Welcome to a review in chi-square test. This video is only going to be the review. Based off of your experience, I'm just going to address, provide the answers to each question. But we're going to first read this, state all the statistical techniques and their corresponding test statistics that we have studied this quarter. I have not written this out directly, but you had to go through the notes to get them from the actual video. But I'm going to go ahead and just show you. So technically we've learned 5 different statistical techniques. One population mean, one population proportion, 2 independent population mean, paired t-test, and 2 independent population proportions. So these are corresponding test statistics. Okay, so just note that. Okay, this is C. Oh, I see why I didn't do that. Okay, the standard error. Okay, fine. That's good. So that being said, I want to go to question 2. Make sure you write this down. Don't just look at this. Don't just look at it. Make sure you write it down. Okay, those are the test statistics. And test statistics are used for what? Hypothesis testing or confidence intervals. They're used for hypothesis testing. Okay. So state all the statistical techniques and the distribution associated with each technique. Right. So in the videos, I legitimately had, we drew a vertical line, and we shaded the area underneath the curve for at least 3 of those techniques, or at least 3 of those techniques. So in terms of stating the statistical distribution, I'm just going to say one population mean can be either the T or the Z. One population proportion is going to be the Z. 2 independent population means, okay, is going to, I'm going to go ahead and show it. 2 independent population means is going to be T. Paired t-test is a T, and then 2 independent population proportions is going to be back to Z. Okay, those are the corresponding distributions for each of the statistical techniques that we've learned thus far. 1 and 2, the first 2 you should have seen before. Okay, the first 2 you should have seen before. Okay, and notice for the test statistics for 2 independent population means, paired t-test, and 2 independent population proportions, they all have a what in them? 0 in the numerator. We'll get to that in a moment. Maybe the next question we'll see. The next question says, state each method again. State them again. While stating the parameter of interest, the parameter that we don't know, we're trying to estimate, and the statistic of interest using symbols. Okay. So, went over this in the past video, but we're reviewing. So, first for one population mean, it should be just mu and x bar. There we go. Mu, x bar. As you can see, we're cascading, we're adding to the table. But the more you do it, the more practice you get. Mu and x bar. For one population proportion, is going to be P and P hat. P and P hat. For 2 independent population means, the first statistical technique that you're supposed to learn in 252 is going to be mu1 minus mu2 and x bar 1 minus x bar 2. Okay. These actually, 1, 2, and 3 are the point estimates when you do confidence intervals. Okay, so keep aware of that. Paired t-test is x bar d and mu d. When it comes to the paired t-test, you are looking for, there's some type of association, and so we're looking at the difference. So the d in paired t-test is always going to be difference. Okay, and then 2 independent population proportions, the actual parameter is going to be P1 minus P2 and P1 hat minus P2. So you can see the parallels between one population means and 2 independent population means, right, when it's mu and mu1 minus mu2, x bar 1 minus x bar 2, but you can also see the parallelisms between one population proportions P and two independent population proportions P1 minus P2. Instead of having 1, you have 2. Okay. All right. The test statistic represents the distance measured in standard error, okay, the distance in standard error between the sample statistic and the hypothesized population parameter and value. So what we're doing is how far, for example, two independent population means, how far is x bar 1 minus x bar 2 from 0 in units of standard errors? How far is x bar d from 0 in units of standard errors? How far is this difference, p1 hat minus p2 hat, from 0 in units of standard errors? The question is, or the idea is, our hypothesized value is this actual difference, because our null hypothesis is that these differences are equal to 0. Okay, that's why it's 0 in each and every one of these in these equations, because we're going to see how far our estimate is from 0 in units of standard error. Oh, please, those that are like, you're hungry for knowledge, rewind that 2 more times, just 2 more times. Okay, just so you can get a deeper understanding and appreciation for this, because it repeats, and we're taking advantage of it repeating. Mind you, quiz. In other words, the test statistic tells us how far our observed data, which is x bar 1 minus x bar 2, x bar d, p1 hat minus p2 hat, is from what we expect. 0, 0, and 0, measured in terms of standard error, our denominator. Okay? So keep this in mind for next week. This is going to keep this in mind for the next video. Because when we're dealing with this, when our test statistics is above 3.5 or below negative 3.5, we have this rule of thumb that we know that this is a rare event. We know that this is a rare event when our test statistic is beyond 3.5 and below negative 3.5. Okay, this makes it a rare event. Okay, so then for each method we examine in this class, provide an interpretation of the test statistic within the context we used. Wow, that's a lot. Also discuss how the p-value enhances our comprehension of the test statistic. Okay. Long story short, you just repeat yourself. Okay. The two independent population means x bar 1 minus x bar 2 is the test statistic standard errors away from 0. Okay. So I'm giving you the equation on how you should articulate this. So, for example, let me do this fast. So in this example, when we're dealing with the memorization, right, our null hypothesis is that mu e minus mu o, even minus odd, is equal to 0. Our test statistic was 7.8947. How you would interpret that is that my difference in sample means, whatever that value might have been, which is, let me see if I can find the exact value. What is the point estimate? 13.9 minus 8.7, which is 5.2. Okay, so in this situation, we would say 5.2 is 7.47, whatever that test statistic was, standard errors from 0. So you provide the difference in the sample means is blank on the test statistic from 0. Okay, so you do the same thing for the pair t-test as well as two independent population proportions. Okay, so now we're done with the review. I would argue some of that most likely was new information, because you would have to have aggregated that thought together. Okay, those thoughts together to formulate this. But I would say one population mean, one population proportion, that shouldn't be new. That shouldn't be new. Okay, it's a review. Okay, good job. Thank you for watching.